Getting started with this, we're gonna try and do this method scramble word. I didn't include everything in here, but the scramble word method. One thing that's important is that it's going to take an uppercase word into it. So does it tell us what kind of word we can swap over here? Let's see. Hopefully, it's still recording here as well, just to make sure we know what kind of. Does it give us a name for the input? Takes in a given. Because we should know, okay, the parameter is word. And I'll write this out a little bit better for you on your test, but just to be clear about like what is the name of the variable coming in. Because when we write our method header statement, it should be public string. Well, I mean, let's just write it out here. Public string, and this is scramble word. And then we're taking in a string. Oh, my face is getting in the way. String word. Okay, so we're taking that in as our. So it's important to know like what variable name do we have to work with, and specifically they're looking for word here, and then it should spit out some sort of string to return. Okay, so a couple things in there that I didn't include in here is that it's all uppercase, which is nice. We don't have to worry about lowercase, uppercase. Like it's just all uppercase, so we don't have to worry about that. So we're going to start with the scrambling process. Begins with the first letter of the word, continues left to right. Great. Two consecutive letters are followed by. So basically, if there's two letters AA, we won't swap them. But if it's A and anything else, then we should swap them. Okay, so I need to loop through my word, and then if we've swapped a word, like if we swapped A and R, for example, here in abracadabra, we check A is the first letter, we find B is the next one, so we'll swap them, and then we want to skip on to start looking at R. So even though we looked at the first letter here, and we found it was A and we switched it with B, the next step in this is to check actually letter 3. We'd want to check the third letter, not the second letter, which is going to mess with our loops a little bit here. If we checked with the second letter, we'd find, oh, hey, A's here as well. We have A and then R. Okay, let's swap it. And we'll check the third. Oh, hey, there's an A here. And we'd eventually move A entirely down the line until it finds another A. So there's a little bit of weirdness in here. If we actually do a letter swap, we're going to have to skip a step. Otherwise, we'll just keep swapping. Hopefully that makes sense. Okay, so we're going to need to run a loop here. I want to control. So if I use a for loop here, it would run from wherever I set my start to my end, and it's gonna run through all of the indexes in between. A for loop doesn't give us a lot of control for this. Like we can't really control the index as easily as we might with a while loop. So I'm going to run this as a while loop. And so I'll write out a little bit of pseudocode, and then I'll do the actual code. If you want to skip the pseudocode part, that's fine. You can just kind of tap a little bit ahead and get to the actual coding part. But I need to do a loop, and then what I want to do is like if there's an A, do something, right? There's gonna be some stuff in here. I would probably do this as like I'll write probably some more if statements in here, but I'll just say like if A exists, then we want to do some stuff because that'll be quickest. If there's not an A, we don't care about it. It can just keep moving on. If an A exists, then we want to if next letter is not A, right? So if we like A and R, we want to swap their locations. Okay, so we want to swap. If we want to do a swap, normally if we want to change their positions, I'm probably going to want to put like a temp. So let's say, we'll just say swap. I'll get into the coding in just a minute. Swap letters. And then we want to skip a space. Does that make sense? So if A exists, so basically if we find an A in there, then we'll run into our actual. If there's not an A, we don't care. If there's an A, we'll run in there and we'll check. We'll say, okay, here's A. Let's check the space next to it. If the space next to it is not A, then we'll swap them, and we want to kind of skip a space and move on to the one afterwards. So I'm going to do some sort of. Well, that's how we'll skip a space, and I'll say else if we're looking at if the letter we're looking at to begin with is not A, then we should just increment count. So I think this should work. We need to loop maybe through the word. Yeah, so I have to do a little bit of work in here to make sure that this works. Okay. Yeah, this should work. Okay, so all right, I'm gonna get to my actual coding in here. Where are we at? Oh, there's actually how I can pause. Anyways, yeah, so we get to the actual coding here. I'm gonna start with I'm gonna do a while loop for this because like this part skipping a step. So versus incrementing, like, do I want to just increment the index by 1, or do I want to increase it by 2 to kind of skip a letter? Let's see how this might work. So we'll do we'll do count is equal to 0. And then I want to do that while count is less than word.length. As you remember, our word is our variable that we're getting in here. So as long as it's less than length, we're going to do some stuff. Let's take our word, and I'm going to use character at, and I'm going to use the variable count to keep track of where I'm at. So to begin with, count 0. So for example, in abracadabra, I'll be checking this first letter here at location 0. So this is going to return us the character at. If that's, we want to check to see if that's A. So we're going to use an equals equals capital A. And I think you could also use double quotations on there. That should work. Yeah. So if word.character at count is equal to A, then we want to do some stuff. Well, let's see. We want to check. Well, I didn't do another if statement here, so we want to check the letter next to it. I think there might be another else statement I need to put in here that I didn't include. So the next letter. So then I would say word. You know, there's going to be something else. I want to make sure that I don't run into in this part. I also want to make sure that I don't run down to the end. Because like when I get to A here, if it's the last letter in the word, I don't want to do any kind of swap, because otherwise I'll try and pull a character from afterwards. So if A exists and not last letter, so in here I need to say if word character at count is equal to A. So if the location, whatever location you're looking at, if it's A and I want to say and count is less than, let's say, word length, run out of space, and I'm going to say -1, because like in this word we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 characters in there, so the length would be 11. But I want to make sure that it shouldn't be in this last space. This last space will be 10, so the length -1. So basically what I'm saying here is if I find any letter A that is in any space before the last one, go ahead and keep working with it. If it's not, if it's in the last space, then we don't want to try and do any kind of swaps here. Okay, so if the letter is A and it's not the very last letter, then we want to check to see word character at count +1. And let's say like not equals to A. Right? So if we take our letter, we find it's A, we're going to check the letter right next door, figure out if it's not A. If it's not A, then I'm going to do a little swap here. I'll say like character temp is equal to, this is going to be a little bit, I don't know if there's a way I could write this a little bit easier. So I would say make like a temporary character, and it's going to be equal to this one, character at count +1. And then I want to say, when we do a swap, we'll do word character at count +1 is equal to word dot character at count. So basically this is going to, we make a temporary variable, like so for example here when we have abracadabra, we have this A and B. We want to store this in a temporary location. And then we want to move A into B's location, and finally move temp back to where A is. So that's what we're doing here. We make a temp to store like this B. That's what's going on right here. Count +1. And then this one, we're going to change count +1 is now going to be equal to this value right here, whatever one we're checking with. And then we need to set word.character at count equal to temp. So that'll swap this temp value back in there. Classic swap technique here. And then what we're going to do is we're going to do count plus, we're going to do plus equals 2. If I don't do count, if I just do count plus plus, then we'll be like A will swap with B, and then we'll start to evaluate whether, we'll again evaluate whether A is next to R. Instead, I'm going to increase it by 2. Oh, I'm running out of space here. I wish I had more space. Let's see. Okay, so that's going to do our swap. That should work pretty well. And I think just down here, I think all I need to do is say otherwise. If it's not any of this garbage nonsense up here, we'll just increase count by 1. So we're checking a location. If we find an A there, we're going to check the value next to it, swap, and then move on to the next space that hasn't been swapped. If we find a location and it's if it's not A, then we should immediately increase the count by 1 to check the next letter to see if it's A. If it's A, then we're going to swap. Oh yeah, and then we did include here, right? We did check to make sure that if the next value is not A, we use this kind of not equals to A. Sure. We could combine this probably all into one line, but that's okay. I think this is going to work. I think this should cover everything. We're working from left to right. We're going to swap. Yeah, I think this should work. Let's evaluate. Let's take a look at this, theirs versus mine. They did a lot of similar things. I think I might have a little error here in doing the word length here, but they use a slightly different one. They use a substring. It might be just because in AP they might not. They have like a certain number of functions that they use so they might not use character at. I mean, you could use substring here. I feel like character at kind of works better, but substring works just as fine too. Yeah. Sure. So the one thing that they did differently, they did this kind of in a smart way, and I should have thought about it because it's a really common thing that we've talked about in class as well, and that's starting with an empty string and then building that string from there. So we can start with this empty results, and then we'll add letters to there as we go. So that's a pretty interesting, it's a good idea. I think I rearranged the letters in there. The way that makes this, the reason that this is nice is they don't have to do that kind of swap mess that we did over here. Like we were doing like this kind of temp and all this stuff. What they say in here basically is, you know, if we find A and then a letter that's not A next to each other, well, let me take this letter, I'll put it in A's position, and then over here, I don't need to swap anything because I know this value, like the swapping value is always going to be A. So down here, so they don't bother with any kind of temp, they just say automatically, hey, that second letter should always be A. You'll notice they do use a while loop, same thing as what we did. They do increase it by 2 whenever this happens. Otherwise, they increase it by 1. Theirs is a little bit different down here because they made this empty string, so they need to actually add something to it. Other than that, let's see, if they come down here with currents less than word length, so I think this is basically, okay, so that's how they encoded for this. That's why they did word length -1, because they wanted to check the last letter and make sure they didn't want to include checking the very last letter. So, because you're right, if there's an A at the end, you don't want to try and swap that with something that's not there. So they ran it like this, and they said basically if we get to the end and the length of this word is shorter than the length of this word that we've built is less than the length of the actual word, then we'll just add that last thing in there. I think that's fine. It's just a different way of approaching the problem. I kind of like ours better, having the while loop in here and then just checking in the if statement to see if we're at the end. But I think just the way they built their problem is just slightly different. So overall, it's good. Yeah, so actually I wouldn't lose a point here, thank good. I was a little bit worried I'm going to mess that up. But overall, they took the same approach. They just used substring. So Clearly, substring is also a good option for this one.